Section 3.4 is on linear programming. So linear programming is a method of finding a maximum or a minimum value of a function. So maybe you're trying to maximize the profit for a business, or you're trying to minimize the cost for a business. And it uses a bunch of constraints. So constraints are basically where you are drawing a bunch of inequalities like we did the other day. So do you guys remember when we showed the shaded region? Like we had a lot of lines overlapping, and then we had the shaded region, and then we found the corner points. That's the kind of stuff we're going to do in this section, okay? And then we're going to plug them into another function called the objective function. All right, so it says, first of all, graph the feasible region for the following constraints. Okay, so this is kind of a review of yesterday. So if I have x is greater than or equal to 0, x equals 0 is the vertical line, that is really the y-axis, right? And if I have everything greater than or equal to that, I have everything to the right of that line. And then I have y is greater than or equal to 1. Y equals 1 is the horizontal line. And then I have everything above that line. So remember, you can do little arrows instead of shading if you want to see. Just shade the final region. All right, now the other two are not solved for y, and you could get it in the form y equals mx plus b, or you can use the x-intercept, y-intercept method. Now, most of the problems in this section will be using the x-intercept, y-intercept method because they're already set up in this general form. So can you guys quickly do those in your head? Are you able to do that quickly? So if you're finding the x-intercept, you plug in 0 for y. So when I plug in 0 for y, I get 2x equals 6. Just treat it as an equal sign. So I get x equals 3. So I was just basically covering up the y, remember? So I get x equals 3. And when I do the same thing, if I'm trying to cover up the x, what do I get for the y-intercept? So I get 0 for x, and when I plugged in 0 for x, I got y equals 2. Are we all good there? So we're going to have 3, 0, and 0, 2, and we draw on a line. You guys can use your ruler or whatever. All right, now the other line, which I'll draw in, let's use green. If I'm finding its x-intercept, I plug in 0 for the y. So quickly in your head, when you plug in 0 for the y, what do we get? Yep, 4. So we're going to have 4, 0. And then the y-intercept, if I plug in 0 for the x, I get 3, exactly. So you would cover up the x value and you get 3 for the y. Does everybody understand how to do that? Okay, so we'll make sure that you guys are all good there. All right, and then we draw that one as well. So we have 4, 0, and then we have 0, 3. Just slightly above it. How about the shading on the black line? I guess I didn't talk about the shading. So when you plug in 0, 0 for the third line that we had, you have 0 is greater than or equal to 6, which is false. Yeah, so you shade away from the 0, 0. So we're shading up. So now that we have this green line, which way am I shading for the green line? Oh gosh, it's super tiny, isn't it? I'm shading towards 0, 0 because now I have 0 is less than or equal to 12, which is true. So it ends up being this tiny little area right in there. It looks like this. Did you guys get something like that? Yours is probably better. I feel like this marker's a little bold sometimes. It's much easier with a pencil. All right, so that's what the final shaded region looks like. Did you guys all see that? Nat, you look confused. You good back there? Yeah. Okay, good. All right, so that's kind of a preview. So that would be finding the feasible region. So the feasible region is just drawing all of the constraints, all of the inequalities, and finding where all of them overlap. That's the feasible region, okay? So if you want to write yourself a little note, feasible region is there. So if I use that word, you know what it means. Okay, so here are the harder ones. All right, it's going to be a little confusing at first, so don't panic. It will be fine. So it says Audrey's Bakery bakes 2 kinds of bread. She bakes honey oat bread and whole grain bread. One batch of honey oat, so I don't know how many loaves of bread are in a batch, but one batch of honey oat bread uses 5 pounds of oats and 3 pounds of flour. But one batch of whole grain bread uses 2 pounds of oats and 3 pounds of flour. The company has a total of 180 pounds of oats and 135 pounds of flour available. So write the constraints for the problem and graph the feasible region. So we have x is our number of batches of honey oat bread, and y is going to be our number of batches of whole grain bread. Okay, so we want to think about what is limited in this problem. So we only have a certain amount of something. What do we have a certain amount of? Flour and oats. Okay, so we're going to start out with flour and then oats. Oh, I should have done oats first and then flour. We'll do oats first and then flour. I would hate to confuse you with my color coding. Okay, so oats, we have 5 pounds of oats for the honey oat, and we have 2 pounds of oats for the whole grain. Okay, so if I make X number of batches of honey oat, then I'm using 5X. Do you guys see that? And I'm using 2Y for the whole grain. So that's our oats. 5 pounds of oats for the honey oat and 2 pounds of oats for the whole grain. How much do I have total? 180. So I want all of this to be less than or equal to 180. All right, and then for flour, I don't know why I said flowers. Flour is going to be 3x, right? 3 pounds of flour for the honey oat, and then 3 pounds of flour, right, for the whole grain. So we're going to have 3x plus 3y is less than or equal to how much flour do I have? 135. Do you guys see how we got those two constraints? So you look for the limited amount, basically. Okay. There are also 2 invisible constraints. Okay, these are like implied constraints. All right, they have to do with the amount of flour and oats that you have. Yes, what do you think? Good, definitely. All right, so we have x that's greater than or equal to 0 and y is greater than or equal to 0. Because we can't have negative 2 pounds of something. Does that make sense? So we have to have at least 0 pounds of oats and flours. Flour. I keep saying flowers. All right. So these all make up our constraints, and when I graph all of them, it's going to give me my feasible region. It's a T. Okay. So the easiest way to graph them is to use the x-intercept and y-intercept method. So I'm going to talk about this 5x plus 2y is less than or equal to 180. So if I plug in 0 for x and if I plug in 0 for y, I'm going to get 2 points. So plugging in 0 for x, are you able to do it in your head? Plugging in 0 for x, what do we get? 2y equals 180, so y is 90. And then if I plug in 0 for y, I get 5x equals 180. That's a little bit harder to do in your head. Do you guys know how to? It is 36. How'd you do it in your head so quickly, Nick? You already did it. Yeah, you can divide by 10, right? 180. If you divide by 5, it's really 180 divided by 10, and then times 2. Divided by 2. Does that make sense? Divide by 10 and then times 2. Isn't that the same as dividing by 5? Quick mental math tricks, right? All right, so we have 0, 90, and 36, 0. All right, so we want to pick a good grid. So what about the x is greater than or equal to 0 and y is greater than or equal to 0? Do you guys think I want to start my grid like this? No. No. So what quadrant am I in? The first quadrant. Do you guys see that? So when I start my grid, I'm actually going to start it right here on the side. And I don't want every single mark to be like 10. I'm going to go with every mark is like 5. Okay, so I'm going to go every 2 marks is 10. 10, 20, 30, 40, 50, 60, 70, 80, because I need to get all the way up to that 0, 90. So I have 0, 90, 10, 20, 30, 40, 50, 60, 70. All right, and I have 36, 0. So 10, 20, 30, 36, a little bit more than 35. And you might want to write like what those y-intercepts are, or y-intercept and x-intercepts are. And then we draw it in. Ruler for this. Could you do what?
What did you do for your exam one?
I just did the same thing. Like every 2 makes 10, so 5, 10, 15, 20. So that. All right, so if I think about my shading, if I plug in 0, 0, I get 0 is less than or equal to 180, which is true, so I shade towards the 0, 0. Which kind of makes sense if you have a limited amount of something, it's going to be less than that, right? More than that would be like, I can't have 500 batches of honey oat and 500 batches of whole grain. And we should always label too. We should say number of batches of honey oat. The number of whole grain. All right, so I'm going to do the next line in red. So I have 3x plus 3y is less than or equal to 135. Has anybody found the x-intercepts and y-intercepts for this? They're the same number.
45.
It is 45. Good. So it's 0, 45, and 45, 0. So 10, 20, 30, 40, 45, 40, 45. And then we draw on our line. All right, and then we shade towards 0, 0 again because 0 is less than or equal to 135 is true. So do we see where the final region is? A lot of people always like blurt out, it's a trapezoid. It's not a trapezoid. It's just a quadrilateral, right? It's a four-sided figure. Do we all see the quadrilateral? So it's here, 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 and here. And we're just going to shade it in. It's always kind of awkward shading. All right, there we go. So we all see that? All right, so that's the first part. So these are like multi-step problems. So this really isn't even done with the problem. So we're going to talk about the next step. So do we all understand how to do that, though? Yeah, we feel good about that. We did that in 3.3. We're good. Do we understand how to find corner points? I don't know. So let's see. So it says in most linear programming problems, we are interested in how to maximize something. So maximize profit, minimize cost. So more advanced math shows that a maximum or minimum value actually occurs on a vertex of the feasible region. So it occurs on one of those corner points. So we don't have to pick any numbers that are on the inside of it. It's always going to happen at one of those four corners. Okay, if it occurs at all. So in order to find the maximum or minimum, we need to understand the difference between bounded and unbounded regions. So sometimes maybe we have something and we have three lines and they're intersecting like that. That would be a bounded region. Do you guys see that? There's like walls on all sides. You could put a fence around that, right? But if I have something like this, that is unbounded. You can't put a fence around it, okay? So sometimes there is no maximum because there's not really like there's no corner points on the edge. Okay, so we'll talk about one like that. So it says we're going to see some of these examples. So the vertex principle just basically says if there is a maximum or minimum value, it happens on one of the corner points. Okay, so number one, it says suppose Audrey's Bakery in the previous example wants to maximize its profit from its bread sales. So one batch of honey oat bread yields a profit of $40 and one batch of whole grain bread yields a profit of $30. So use the profit information and data from the previous problem to find out how many batches of each bread the bakery should bake, okay? So we're going to write our profit equation, so P for profit. So X was our number of batches of honey oat bread. And so for every single one of those batches, we're making a total of $40. So we're going to have 40X. Do you see that? And every single batch of whole grain bread makes $30, so we have 30Y. Do not worry that your function has a new variable P in it. Okay, we're not going to worry about that at all. So we're going to have some kind of equation with X and Y, and then we're going to have either profit or cost or whatever that we're setting it equal to. This is called the objective function. So objective function. Okay, so we need to find the corner points. And I would say, for the most part, almost every single corner point will be very easy to find. There's usually only one that you have to find using another method. So let's look at our picture. So kind of go back to the picture. Okay, I'm going to label these corner points. So I'm going to call the one down here point A. I'm going to call this one point B, C, and D. So I just kind of went around. So this corner point was A, B, C, and D. It doesn't matter what your A, B, C, and D are. Okay, so yours could be other ones, but we'll kind of keep it consistent for the notes. All right, so are some of these easy to find? Well, A is what corner point? 0, 0. What's B? Yeah, that was the 45 one. It was coming from here, right? So you can write 45 next to it if you need to. All right, and then same thing with D. We had 36 next to that, and then C, we don't know. Can you guys guess? Did you guys have a really nice graph, and can you tell perfectly what that should be? 30 comma something. I don't know. We'll see. So we're not sure about that one, but we at least know A, B, and D. Okay, so tell me what these are. So A was 0, 0. B was 0, comma, what was it, 45? C we don't know, so we'll leave it blank. And then D we knew was 36, comma 0, exactly. You got what? That's what you think for C? Okay, so we're not sure. Maybe our graphs say different things. Maybe Nick's looks like 30, yours looks like 25. I did not draw a very good line in the first class, and mine was really far off. Okay, that's why I was like using the, I know, I should have had a ruler. I'm a bad math teacher. All right, so if I want to find the corner point that we're missing, all right, basically I have two lines that are intersecting, and I'm trying to find where they're intersecting. You can do that with a graph, but what were the other two methods that we learned? Yeah, we use substitution or elimination, right? So use substitution, use substitution or elimination. All right, so what two lines are intersecting to form C? Well, it wasn't the x equals 0 and the y equals 0, right? It was these other two lines. So let's use them. So we're going to say 5x plus 2y equals 180, and then 3x plus 3y equals 135. Now notice how I'm just saying equals. I just have to say equals because it's actually on the line. So I don't need the less than or equal to. Okay, then we quickly do substitution or elimination. So I multiply by 3, I multiply by -2. So I get 15x plus 6y equals 540. And I have -6x minus 6y equals -270. So I end up getting 15 minus 6 is going to be 9. So 9x equals 270, which gives me 30. And then I plug back in to find the other one. So 3 times 30 plus 3y equals 135. I think I end up getting 15. You guys can check, but I think it's 30, comma 15. All right, does that make sense? So that's the point for C. That's what we just found, 30, comma 15. It's a long problem, isn't it? There's a lot. All right, final step. We're trying to maximize the profit equation. So I usually do like a little table, and I say, oh, P is equal to 40x plus 30y. And all I do is I plug each of these points into the profit equation to find the profit for each one. So the first point, what do we get for a profit? 0. Doesn't that make sense? If you sell 0 loaves of each one, probably not going to make any money. Sometimes profit could be negative. Sometimes you lose money, right? In that case, I think it really would be negative. All right, if I plug in 0 and 45, I get 40 times 0 is 0 plus 30 times 45. I think that's 13,500, or not 13,000, what am I talking about? 1,350. That'd be a lot for bread to make $13,000. All right, and this one, so I'm going to plug in 30 and 15. So 1,200 plus 450, 1,650. Is that right? And the last one, plug in 36 and then 0. So what do we get? 1,440. So what's our maximum amount? Yeah, so just kind of write a little, it doesn't have to be a full sentence, but just say max of 1,650. And then you can just say at what corner point? At like 30, comma 15. Or you could say like 30 batches of honey oat bread and 15 batches of whole grain bread. So in the first class they were saying, so it's probably going to be the one that has at least, you know, like some of each thing, right? So it would have to be the point C because you don't want to make 0 of the whole grain and 0 of the honey oat. But you could. Like maybe you're making all this whole grain bread and you're not making as much money as you would have if you used all the flour for the honey oat. Does that make sense? So sometimes it is the ones that have zeros in them. It's kind of tricky. So you should check all of them. All right. I know that was a lot. Does your head feel like you're going to explode? Somebody say no. Somebody say yes.
But,
Yeah.
How did we get the 3 and -2? How did we get those?
The 3 and -2.
As in, for C, how exactly did you get those specific numbers?
30, comma 15.
Well, I mean, the 3 and the -2. I'm still trying to figure out.
Oh, because we wanted to eliminate either x's or y's, so we could make both of these 15 or both of these 6. Yeah, so it's the elimination method.
Regular, okay,
Yeah.
that makes sense.
All right, so same idea here. So it says the annual profit. This is more how your homework is. It's not like the big story problem necessarily. There are some on the back page that are kind of, you have to set them up, but they're not as hard as that first one. All right, so the annual profit in millions earned by a business is given by the equation P equals y plus 2x, where x and y are subject to the constraints given below. Find the maximum profit of the business. Okay, so again, we do have the x is greater than or equal to 0 and y is greater than or equal to 0, so that tells us that we're in the first quadrant. And then we quickly find our x-intercepts and y-intercepts for each of these lines. So the first one, when I plug in 0 for x, I get 120 for y. When I plug in 0 for y, I get 40 for x. So I have 0, 120, and I have 40, 0. This time, let's go with tens on the grid. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. I think it's like 3 away from the top. 0, 120. And then 40, 0. And then we draw the line in. Mine was a little off. That was off the other direction. Whatever. All right, so it's like that. And then when we plug in 0, 0, we get 0 is less than or equal to 120, which is true. So we're shading towards 0, 0. So we were already in the first quadrant. So right now, you don't have to draw this in, but we are right now in this little triangle right there. Okay? So then the next one. So I have x plus y equals 60. Can you guys find the x-intercept and y-intercept for that? Yeah, 60. 0, 60, and 60, 0. All right, and then draw your line in again. And if your line's perfect, then you don't have to do the thing where you find C, if you can tell where it is. I think it looks like 30, 30. I don't know. If you want to check 30, 30 in both of those and see if it works, let me know. So 30 plus 30, is that equal to 60? Yeah. 3 times 30 plus 30, is that equal to 120? Yeah, so I think it is 30, 30. So we were lucky that time, and we can see that that point is 30, 30. That one is also shaded below because 0 is less than or equal to 60, means shade towards 0, 0. So our final region is right in here. Where do you see it? All right, and so then we have our corner points. So we would want to find A, B, C, and D. And we actually have all of them. Okay, so A is going to be the point 0, 0. B is going to be the point 0, 60, is that right? Yeah. C is going to be, we just found it, 30, 30, but if we didn't know it, then we would do substitution or elimination to find it. And then D is going to be the point, I didn't label it, 40, 0. And then we plug it into the profit equation, which is y plus 2x. So be careful, the y's first, don't be thrown off by that. So we get the profit equals 0. The next profit is going to be 60 plus 2 times 0, right? Be careful. So it's 60. So don't plug it in for the wrong one. The next one's going to be 30 plus 2 times 30, which is 90. And the last one is going to be 0 plus 2 times 40, which is 80. See, that didn't take too long, did it? So what's our max profit? $90? $90 million. Yeah, that's a big difference. Don't mess up the decimal point on something like that, man. $90 million, and it's at 30, 30, right? It will not always be at point C, like I was saying earlier. So don't just assume it's at C. All right, next up. So, well, let's skip this one. Well, I don't know, we can do it. All right, so number 3. So this is one that's clearly not like a actual like profit equation or anything because we have x is less than or equal to 0. But it's still, you still need to find the corner points and so on. So let's do that. So we have x is less than or equal to 0, which means I'm on the left side. So here's my x equals 0. I'm on the left side of the coordinate plane. Y is greater than or equal to 0. I'm above. So what quadrant am I in? Not the 4th. The quadrant 2, right. I'm in the 2nd quadrant. All right, now the next one is y is less than or equal to 9. That is just a horizontal line through 9. And then the last one is y is less than or equal to negative 2x minus 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to go up 2, left 1, up 2, left 1. Do you guys know where I'm going to cross the line, the x-axis at? Any ideas? You guys know what this point is right there? Yeah, it's at 3.5. Can you guys kind of see why that's going to be 3.5? Because you're going up 2 and over 1, up 2, over 1. So if you were at negative 7, then you're going to be over like 3.5. All right, but if you're not sure, we can find that. All right, so the y is less than or equal to 9 is going to be below. And we were already in quadrant 2, so we were right now, we're here. All right, and then the greater than or equal to negative 2x minus 7 is going to be above. So can you see where it is? Bless you. It's right in here. This is a trapezoid shape this time. All right, so we need to find the 4 corner points. You can call A, B, C, and D whatever you want. I usually go clockwise. I don't know why. It doesn't matter. And we have to find those points. So A is 0, 0. B is, we said negative 3.5 comma 0, but if you didn't know, you would find B by using the line y equals 0. And you said that it crossed this line, y equals negative 2x minus 7. So you would substitute the 0n for your y, and then you would solve. So you say, okay, 0 equals negative 2x minus, that's a 7. Doesn't look like a good 7. Minus 7, and you get x equals negative 3.5. So B is negative 3.5 comma 0. Okay, looks good. Get it? Okay.
No, yeah.
No, but yeah. I'm not very confident. All right, let me know if you have a specific question.
What I should have drawing the graphic.
Yeah. I think, like I've told you before, I was an art major as well, which is, I realize is a gift of mine and not necessarily a gift of other people. So it was interesting when I used to teach geometry because I'd be like, okay, well, let's see, we have a cube, and then on top of the cube we have a, you know, and I would draw all these things, and people are like, how are you drawing that so fast? I don't know. We're there. All right, so C, we need to find C. So for finding C, we want to know what lines are intersecting for C. So C was y equals 9, and then that was the y equals negative 2x minus 7. Yeah, and sometimes it helps if you kind of label your lines as you go. So like line 1, line 2, line 3. All right, so we do the same kind of thing. We're going to plug in 9 for y and then solve it. So we're substituting. So I get 9 equals negative 2x minus 7. Add the 7 over, we get 16. So x equals negative 8. What's the y value that goes with negative 8? 9, right? Because we had y equals 9. So it's negative 8 comma 9. And then d we know. So d is 0 comma 9. And then we plug into the profit equation. So when we plug into our profit equation, we had negative 2x minus 4y. That's never good when your business has negative numbers for profit. Maybe you're just volunteering. It's a non-for-profit. You're losing money. I don't know. All right, so we get 0. We get negative 2 times negative 3.5, and then plus 0, so 7. We get negative 2 times negative 8, minus 4 times 9. So, no, let's see, 16 minus 36, negative 20. So don't do that one. All right, that would be like a minimum. All right, and then 0, 9. So we can plug in 0, we can plug in 9, we get negative 36. Okay, this one said maximize, not minimize. Some of them might say minimize on your homework, you never know. So minimize would be finding the smallest amount. So this is our maximum. So it's a max of 7 at negative 3.5, 0. So why on your homework do I not want you saying max of 7 at B?
Because not everybody's views.
Yeah, what's B? B could be anything. B could be whatever you had it. Okay? All right. Let's look, kind of preview the last one here. I guess I have a couple more. Sometimes, so this is kind of the same idea. It's like setting up the constraints. So this talks about the hours for Blu-ray palette, the hours for the television palette. So these are like the hours in the electronics department that are available. So it's like 3x plus 4y is less than or equal to 180. We're going to skip that one. And then this one ends up being something that's unbounded. So when you have something that's unbounded, basically you graph all of the lines. Like maybe you have something like that. And then it's like this. And we'll do one more. So maybe it's like that. And then you would try those corner points, the two that you have. But you would also pick any point. It doesn't matter what point. Pick any point on the inside to test as well. If the point on the inside is your maximum, then there is no maximum, right? It's an unbounded profit or an unbounded cost or whatever. Does that make sense? You guys see what I'm saying? All right, so I'll skip that one as well. All right, let me pass out your homework.